Regulators. Regulators! Mount up.
Well, good morning, good afternoon, or good evening, depending on what time of day it is that you're watching this lesson. In this video, I'm going to go over with you how to graph systems of linear inequalities, right? So it's 12.2. We're graphing systems of linear inequalities. Because before we do that, think about this quote right here. The expert in anything was once a beginner. Right? You're beginning right now. You're in Algebra 1. You're beginning your journey. You're going to be an expert pretty soon if you work at it and you want it enough. Okay? So remember, the expert in anything was once a beginner. Okay, and before we jump into that, I want to go back to these examples we had in the last lesson that I did with you. Okay, we solved these systems by graphing. In this first system we said was a dependent system, and we got a solution of 4, -2. The second one had no solution. These were parallel lines. We called it an inconsistent system. This third one, there were infinite solutions. It was a coincident lines that were the same line, so we said it was a consistent system but dependent. Okay, this first one was a consistent system but independent. I want to show you how we could have done these by graphing. So I'm going to grab the calculator here, and I'm going to clear out anything that I have in here. I'm going to show you how to graph these quickly and easily to get the solution on the calculator. Okay, we could go through and solve this for y, and if we did that, remember there's the two-step process. We take the 2x over. So what we'd have is we'd have 2 minus 2x. Okay, that's what 3y would equal, and then we divide by 3 to get y by itself. For the second one, we take the 3x over. So in parentheses, I'm going to put 16 minus 3x. And then I'm going to divide that by the number in front of the y, the -2. That's the quickest, easiest way to graph a linear equation that's written in standard form. Do a parenthesis, do the answer, then take the x term over, so it's 2 minus 2x in parentheses divided by 3. The other one's 16 minus 3x divided by -2. Now, I've got a weird window as I was doing something earlier, so I'm going to hit viewing window and then standard. It makes it go -10 to 10 for x and y. Then I'm going to graph it again. Okay. Point where they intersect is the answer. So I hit G solve and then F5 is intersect. Guys, look at that. X is 4, Y is -2. It's exactly what we got yesterday working it out by hand. Okay. It's a dependent system because they intersect. It's consistent because they intersect, and they intersect at one point, so it's dependent. Okay, now watch if we do this second one. I go back in here. I'll clear these things out. So F2 to delete, F1 says yes. F2 to delete, F1 to say yes. First equation is 2x plus 4. The second equation, we get 4x plus 8 is 2y. So all I have to do is take the 4x plus 8. Whoops, sabotage. Bam. 4x plus 8 and divide it by 2. I'll regraph those. I only see one line. Watch this. I hit G-solve intersect. It actually tells me there's an answer at -10, -16. But if I keep moving, there's infinite answers. Right? So you got to watch for this if you're trying to do it by graphing when you get the, whoops, because this one we said, did I have these backwards? Let's see, this is negative, no. Yeah, this was, if I divide, this is the same. This was the no solution. Okay, in the calculator, let's exit this so we just look at the graph. Right, it only shows us one line, and when we do the G-solve intersect, the calculator thinks there's a solution. We have to know there's infinite solutions. Right, we keep going, there's infinite solutions. Because these are actually the same line. Actually, I had these two things backwards. I'm glad we did this together. Boom. This one had infinite solutions because if we solved this second equation here and we divide everything by 2, we get that y equals 2x plus 4, right? These are the same equation, so they're same line, so there's infinite solutions, right? The other one, they intersected at 4, negative 2. So I actually had those things backwards, okay? Now, let's see what happens when there's no solution, when the lines are parallel. So if we come back in here, I exit this. So if I don't want to delete stuff, I can just start typing and it will delete. So I'll do 3 halves x. Okay, then here I'll take the 3x over. So I'll get 6 minus 3x. Put that in parentheses, then divide it by negative 2. Now looking at this, I'm a little worried up here. I like to put my fractions in parentheses on this. Because I want to make sure it does 3 divided by 2, then it multiplies it by x. I don't want that x in the denominator. Okay, now if I draw this, now we see 2 parallel lines. Watch what happens if we hit G-solve intersect. It says it's not found. That's because there is no answer. Okay, there's no solution. They're parallel lines. There is no answer. Okay, when they're 2 lines that are actually the same line, they coincide, there's infinite solutions. Okay, so I just want to go back over on how you could do that by graphing those ones we did in the last lesson. Okay, now when we hit this lesson, remember, one day you're going to be an expert. Right now you're a beginner. Just keep working at it. Okay, we're going to graph the solutions to inequalities, a system of linear inequalities. Okay, so we're going to do this just like yesterday, except we're going to graph inequalities. So y is greater than 3x. We want to graph that line. So the y-intercept is 0. Then the slope is 3, so I'm going to go up 1, 2, 3, and over 1. Okay, I'm going to go up 1, 2, 3, to the right 1, up 3, to the right 1. If I do it in reverse, I go down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. Okay, now when I connect these points, since there's no equal sign in the inequality, I use a broken line. I use a dotted line or a dashed line because I don't want people to include points on the line. And now this says greater than, so what I like to do is just lightly sketch. If I'm at the y-intercept, y's that get greater than or above, I lightly sketch some arrows. Tell me when I shade this in, I'm only going to shade above this line. Okay, if I just had one line, there's my answer. I just shade there. But I've got another inequality here. So this one I'm going to solve by y just by taking the 2x to the other side. I'm going to get y is less than negative 2x plus 4. So the y-intercept is 1, 2, 3, 4. The slope is negative 2, so I'm going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. Right, really down 2 and to the right 1, because I could go up 2 and to the left 1, up 2 and to the left 1. I'd be on the same line. Now, this is inequality, so again, I'm going to use a dashed line. Not a solid line, but a dashed line. And now, if we were doing like yesterday, maybe I'll put the arrows on this. Yesterday I didn't. The answer, if these were just trying to find the point where they intersect, I see that point right there is 2, 1. Right? But we want the inequality. So now on this, less than means below. So in this second line, I want everything below the y-intercept. Then I look for where these match up. There's where I shade in. So the solution is anything in this region right here. Right? Anything below, maybe I'll extend this so we see this better. I'll extend this line on out. Anything below this line, but above the other line, is a solution to our system. Okay, Now, when you do these, you're going to want to pick a point in the feasible region, right? That's our area here that I shaded in. I want to pick some point over here. Maybe I'll just randomly come over here to 1, 2, 3. I'll take this point right here. X is -3, y is +3. If I plug that in, the original equation here, is 3 greater than 3 times -3? Yeah, 3 is greater than -9. So it makes the first inequality true. If I plug it in the second one, I've got 2 times -3 plus 3. Is that less than 4? Well, 2 times -3 is -6 plus 3. That's going to be -3. That's less than 4. So that's my solution. I've checked it. I checked the feasible region. Okay. Now, because that's how you do it without a calculator. If you can use your calculator, you can do this. I'm going to clear these things out. Now, there's a nice thing about these calculators. It's right here. It says type right above F3. So I'm going to hit F3. And these are different types of graphs I can do. I'm going to hit F6 to scroll over, and look at this right here. If I want to graph y is greater than 3x, I hit that, and then I do 3x, and it's going to graph y is greater than 3x. My other one is y is less than -2x plus 4. So I hit type, I go over, I hit the y is less than -2x plus 4. I'll draw that. You guys look at that. Some people might say that's deja vu all over again. Because that, my friends, looks just like our graph. All right, look how easy the calculator made it. All right, something like this you should never miss on the calculator. Okay, look also how the calculator does dashed lines. Because we did less than and greater than, there were no equal signs. Okay, let's try another one. Let's do this one right here. So we'll do it by hand first, and then we'll check it with the calculator. So first thing I want to do is get these in y equals mx plus b form, slope-intercept form. So I'm going to take the 2x over. So I have -3y is less than -2x. I'll divide by -3. So y is going to be greater than 2/3 x. Okay, that's one inequality I want to graph. This other one, I'll take the 2x over. I'll get 3y is greater than or equal to 12 minus 2x. All right. Then I'll divide everything by 3. And I'll get y is greater than or equal to, I'm going to write the -2/3 x first. Then it's plus 12 divided by 3 is 4. Okay, then I'll graph that. So y is greater than 2/3 x. The y-intercept is 0. The slope is 2/3, so I'll go up 2 and to the right 3. 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 Could also go, look at this. I started going up 2 and over 2. That's not good, you guys. Up 2 and over 1, 2, 3. Up 2 and to the right 1, 2, 3. Up 2 and to the right 1, 2, 3. I could go down 2 and to the left 1, 2, 3. Down 2 and to the left 1, 2, 3. Down 2 and to the left 1, 2, 3. Okay, I'm going to connect those lines with a broken line or dashed line because there's no inequality, there's no equals in the inequality. So I'm going to get that graph right there. I'll extend it out this way. Okay. Now it says greater than, so I'm going to think to myself, okay, only above this line. The y's get greater above the line. Now I'll graph this other one also. So let's see, the y-intercept is 4. 1, 2, 3, 4. Slope is -2/3. So I'll go down 1, 2, 3 and over 1, 2. Whoops, I'll go down 1, 2 and over 1, 2, 3. Down 1, 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. I could also go up 2 and to the left 1, 2, 1, 2, 3. I'd be back on the line. Up 2 and to the left 1, 2, 3. Up 2 and to the left 3. Okay. Now I connect these with a solid line because there's an equal sign in the inequality. So I'll connect them with a solid line. Now, because if this is what we did in the last lesson, we're looking for the point where they intersect. The answer is 1, 2, 3, 1, 2. So it's the point 3, 2. That's where they intersect. But we want the region where 2x minus 3y is less than 0, and 2x plus 3y is greater or equal to 12. So this one was greater, so I want to shade above this solid line. So I look for where my arrows line up. That's where I shade. So the solution is anything in this region right here. Right. If I want to check, I'll pick any point in my shaded region. And this time I'm going to pick something on the y-axis. 1, 2, 3, 4, 5. I'll pick this point right here. Let's say this is the point where x is 6 and y is 0. Right? If I take the top equation, I put 6 in for x, I'm going to get 2 times 6 minus 3 times 0, because I'll put 0 in for y, is that. Whoops. Guys, look at that. That's silly right there. I wrote those backwards. Right? Don't make those kind of careless mistakes. You know what you're doing. You just make a goofy, careless mistake. This point right here, x is 0 and y is 1, 2, 3, 4, 5, 6. Right? X was 0 and y was 6. So if I do 2 times 0 minus 3 times 6, is that less than 0? Well, yeah, negative 18 is less than 0. If I plug it in the second one, I'll do 2 times 0 plus 3 times 6. We want that to be greater or equal to 12. 3 times 6 is 18. That's greater than or equal to 12. Boom, we got the right answer. Now, if I want to check it on my calculator, I'm going to exit out of this. I'm going to come back here. I'm going to delete that. And I'm going to delete that. Okay, now, if I want to graph this top one, let's say maybe I made a mistake solving for y. If I'm using my calculator, I'm just going to graph that like it is. So I'm going to take the 2x over and divide it by negative 3. So I want y to be less than, right? So I've got the y is less than there. I'm going to have negative 2x divided by negative 3. Okay, now the other one here, if I take it over, I want y to be greater than or equal to. So this is still have less than there. So I've got to go to type, go over here, go to the greater than or equal to, and then I'm going to subtract 2x from 12. So I'm going to have 12 minus 2x, and then I'm going to divide that by 3. Oh, interesting. So you guys, when I graph it, they're shading a different part. That makes me think, hey, I must have made a mistake typing this in. Let's see, y would be less than. Well, and here you guys go. I divided by a negative number, so right here I should have flipped the inequality in this first one. Right? That's the difference between equal signs and inequalities. When I divide by the negative 3, I have to flip the inequality. So I need to go to type. I need to go over here. This should have been, instead of less than, greater than. Y should have been greater than negative 2x divided by 3. Divided by negative 3. Let's try that again. Oh, look at it, still going the same way. So I'm not liking that. Let's see. Oh, as for some reason I didn't clear that out. Let's try this again. Delete. Go to type. I want y is greater than, which I do. Y is greater than. And I'm doing negative 2x divided by negative 3. All right, this time it got the greater than in there. I don't think it did last time. There we go. So, you guys, the calculators are nice, but we need to make sure we type things in correctly. Right. There's your graph, matches our graph. All right, let's do another one here. All right, so on this one, If I solve this first equation for y, I'm going to get y is less than negative x plus 6. Okay, this next one, if I divide everything by 2, well, actually, let's do them one at a time. So this one, the y-intercept is 6. 1, 2, 3, 4, 5, 6. Slope is negative 1, so I go down 1 over 1. Because I could even go down 6 and over 1, 2, 3, 4, 5, 6. Right? Because 6 over 6 is 1. I could go up 1, 2, 3, 4, and to the left 1, 2, 3, 4. As long as I do the same thing, right? From here I could go down 1, 2, 3, 4, go over 1, 2, 3, 4, to the right 4. As long as I do the same thing, I'm getting negative 1. Okay. And this is just a plain less than, no equal sign, so I'll use a dashed line to connect these. So there is the graph of y. Well, this is actually y equals negative x plus 6. Now we want less than, so that means I want to shade, when I shade, only below this line. Right? Less than is below. Now the next one, I'm going to take the 2x over. So I'll have 2y is greater or equal to negative 2x minus 12. And I'll divide everything by 2. I'll get y is greater than or equal to negative x minus 6. All right, so right away I'm noticing that these lines are parallel. They're never going to intersect. So when I graph this one, I go down 1, 2, 3, 4, 5, 6 on the y-axis. Slope is negative 1, so I go down 1 over 1, down 1 over 1, down 1 to the right 1. I can keep doing that up to the left. Right? Or I could just go 1, 2, 3, 4, 5, 6, 7 up, and 1, 2, 3, 4, 5, 6, 7 over. Right? Line those up. There's an equal sign in this, so I use a solid line. I draw the line through those points. Okay, so this one said y is greater than or equal to, so that's everything above the line. Now, if we were just solving a system of linear equations, we'd say no solution. But since this is a system of linear inequalities, then we shade in everything above this line and everything below that line. So we shade that right there in. Any point in this shaded region, we call it the feasible region, is a solution to this system of linear inequalities. Okay, and if I want to check it, let's pick the easiest point right here, 0, 0. If I put 0 in for x and 0 for y, I get 0 is less than 6. That's true. If I put 0 in here for x, 0 for y, I get 0 is greater than or equal to negative 12. That's also true. So I've checked it out. Okay. Let's look at this on our calculator. All right, let's see if I can graph this one a little bit better. I'll delete these out. And now when I come up here, I'm going to hit type. I'm going to go over here. I want y is less than. So I'm going to hit the y is less than. See how it changed it up there? I'm going to do negative x plus 6. Then for the other one, I'm going to hit type. I'm going to go over here. This time I want y is greater than or equal to. So I'll go with the greater than or equal to. Put that in there. And I'll put negative x minus 6. I'll graph those. Boom. Look at that. You guys, it's that easy. All right, the calculator's nice for confirmation. Let's do one more here. Let's do one more. Okay. So let's see this top equation. I'm going to take the 12 and the 3x over. So I'm going to get 2y is greater than or equal to. That stays there. 3x goes over, becomes negative. Negative 12 goes over, becomes positive. And I'll divide everything by 2. So I get y is greater than or equal to negative 3/2 x plus 6. So the y-intercept is 1, 2, 3, 4, 5, 6. So I put a point on the y-axis at 6. Slope's negative 3/2, so I go down 1, 2, 3 to the right 2, go down 3 to the right 2, down 3 to the right 2, down 1, 2, 3 to the right 2, even do it again, down 1, 2, 3 to the right 2. I could go up 1, 2, 3 and to the left 2. Now, when I draw my line, there's an equals in the inequality. So I use a solid line. All right. And let's see, it said y is greater than or equal to. So the y's get bigger when you go up. So it's everything above this line. So when I shade in, it's only going to be up here. And now the second inequality here, this trips people up sometimes, and it really shouldn't. You got x is less than -2 plus y. So you guys, I'm just going to add 2 to both sides. And I'll get x plus 2 is less than y. Right, all I did there is I took the 2 to the other side, and it became positive. Okay. Now the y's on the greater side, so this is like saying y is greater than x plus 2. Right? Y is greater than x plus 2. I just rewrote it this way. So now the y-intercept is 2. The slope is 1, so I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Right? Just keep doing that. It's going to be a line that goes right like that. I could go to the left 1, down 1, down 1 to the left 1. All right, the line's going to go like this. You guys, again, you don't have to put in all these lines like I'm doing. I'm just showing you that it keeps going like that. There's no equal sign in this inequality. So when I connect these, I'm going to use a broken line or a dashed line, whatever, however you want to say it. Okay. So there's the graph of the line y equals x plus 2, not including points on the graph. And then we want all the y's greater than that. So again, greater than is above the line. So I look, where do they match up? They match up right there. So here's my feasible region. Right, that's what I shade in, right there. Any point in that region makes these two inequalities true. If I want to check it, maybe I'll come over here, see 1, 2, 1, 2, 3, 4, 5, 6. The point 26 is in there. So if I put 2 in for x, I'll get 3 times 2 is 6, plus 6 for y, 2 times 6 is 12. If I subtract 12, I get 18 minus 12, I get 6. That's greater than or equal to 0. So that one's true. The second one, if I put 2 in for x, is that less than -2 plus y, which is 6? Well, 2 is less than 4. So I like my answers. Okay. Now, check it on the calculator. Let's go through this again. I'll delete both of these. The first one I'm going to graph is the x. Y is greater than or equal to -3/2 x plus 6. So I'm going to go to type. I'm going to go over to equals, or the type. I'm going to do the greater than or equal to. And then in parentheses, I'm going to put -3/2. Okay, I like to be safe. I like to put my fractions in parentheses. -3/2 x plus 6. In the y sub 2, I'm going to put y is greater than x plus 2. So I'm going to go to type. I'm going to go over here. Y is greater than, get the greater than x plus 2. I'll graph those. Look at that. Ladies and gentlemen, that is deja vu all over again. That looks just like our graph. Okay, so graphing these linear inequalities, systems of linear inequalities, should be easy. Right? It's nothing new. We're just putting things together. Now, to finish it off, let's do a word problem, because I know everybody loves word problems. Okay. Drama Club is selling tickets to the school play. School's auditorium can seat 700 people. They're charging $5 for adults, $3 for students. They want to bring in at least $2,400. Let's write 2 inequalities to represent this scenario. All right. Now, I'm going to let x be the adults and y be the students. All right, so I'm going to define them. X is the number of adult tickets sold. And Y is going to be the number of student tickets sold. So first off, the school's auditorium can seat 700 people. So I know the adults plus the students has to be less than or equal to 700. All right, they can't fit more than 700 people in there. Oh, because I didn't notice I already had some things on here. I want to go through that here. So let's take that off. Okay, now they want to bring in at least $2,400. So I know the money they make, they want it to be greater than or equal to 2,400. Right? It could equal 2,400 or it could be more. That's at least. Then they're charging $5 for adults. So I'd say 5x plus $3 for students, 3y. So there's my two inequalities. Okay. Now I want to graph these inequalities. So here's a little graph here. If y is the students, then over here is going to be the students. Student tickets sold, and here's going to be the adults. All right, and I'll label this tickets sold. All right, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like this goes 20 to 20 both ways. So I'm gonna tick this off, and this is gonna be, I'm gonna go by 50s. 50, 100, 150, 200, then 300, 400, 500. This one will be 600, 700, 800. Let's see, 900. This will be 1,000 tickets sold. Same thing over this way. This would be 100. This one would be 200, 300, 400, 500, 600. Here would be 700, 800 tickets, 900, and then 1,000. Because I probably should have said go by hundreds and just call this 1, 2, so forth, but we got it in there. Okay, now to graph these, this equation right here, I can just make it y is less than or equal to negative x plus 700. Right? This is the number of tickets sold. So the y-intercept is 700. I could do the slope. I can go down 1 over 1. Or, you guys, I could even think of x and y-intercepts. If x is 0, y is 700. If y is 0, x is 700. So that's just going to be a line going through those 2 points. So I'm going to sketch a line that goes from here to there. And then since it says less than or equal to, I know my feasible regions underneath that. Now this next one I'll solve. I'll take the 5x over. I'll get 3y is greater than or equal to negative 5x plus 2,400. I'll divide everything by 3. And y is going to be greater than or equal to negative 5/3 x plus 800. Okay, so on this one, the y-intercept is 800. Slope is negative 5/3. So I'll go down 1, 2, 3, 4, 500, and over 1, 2, 300. All right, and then again, I can't go down another 500 and over, so I'm going to draw my line through those 2 points. So I'll go here to there and just extend it on. Okay. Now, it says greater than or equal to, so it's anything above this line, which then tells me this is my feasible region right here. Okay, any combination of tickets sold in that region, then they have less than or equal to 700 people there, and they made 2,400 or more dollars. Okay. Now, part C says, where's the intersection of the 2 lines? Well, if I was accurate here, and it looks like I might be, This point right here is the point, let's see, 150, 550, right? 150 or 150, 550, depending on how you pronounce 50. Okay, now X is the number of student tickets sold, or X is the number of adult tickets sold, Y is the students. So that means they intersect when they sold 150 adult tickets and 550 student tickets. Then they made exactly, then they sold out, right? They sold all 700 seats. They sold out and made $2,400. Okay, so they sold out the stadium, they maxed it out, the auditorium, and they made the minimum amount of money they wanted. Okay. Now, what does the shaded region represent? The shaded region represents any combination of ticket sales, ticket of 700 or less, where they make $2,400 or more. Because if you think about it, when we look at it, this line with the 800 is the y-intercept. That was the money line, how much money they make. So anything above that, they make more than $2,400. The other line was the ticket sales. Anything below that, they're selling less than 700 tickets. Right? So this gives them, right here at the point of intersection, 150 adult, 550 student, they made exactly $2,400. But the rest of this feasible region, they made more than $2,400. Right? When we're above that line, they made more. So they really want stuff in the shaded region. Then they make more money and they sell fewer tickets. All right. Guys, the key to these kind of problems is stay up on it. Practice, practice, practice. Do the homework, check your answers, and most of all, endeavor to persevere.